Alright, so let's look at this example problem. A car on a slick surface is traveling initially at 10 meters per second when the driver hits the brakes. The car slides to a stop by decelerating at 1.5 meters per second squared. We want to know how long it takes the car to come to a stop, and if the car has 20 meters of road left before sliding into a meadow, does the car actually stay on the road? So let's go through this problem. We have a car traveling on a slick surface initially at 10 meters per second. So initially tells us this is going to be an initial value, and the fact that this 10 has units of meters per second tell us that it's the initial velocity. So that's what I've written down here. The driver then hits the brakes, and then the car slides to a stop. That tells us, because we're coming to a stop and not moving anymore, that the final velocity is 0. And we're told that we're decelerating at 1.5 meters per second squared. So since we're decelerating, and we have units here of meters per second squared, that tells us that that's our acceleration or deceleration. So I've written down a negative 1.5 meters per second squared. So we want to know how long it takes, so that's time. So time is my first unknown. And we want to know if the car slides off the road, essentially. So we have a 20-meter window to come to a stop, so we want to know how far does the car go before coming to a stop. So displacement is going to be our unknown for part B. Now, given that we don't know the displacement when we start A, we only have one real option. And that is to use the fact that the velocity final equals velocity initial plus acceleration times time. So for velocity final, I plugged in the 0 meters per second. For the initial velocity, I plugged in the 10 meters per second. For acceleration, I plugged in negative 1.5 meters per second squared, and then time is our unknown. So to solve this, the first thing I did was subtract the 10 meters per second to the other side. So we have a negative 10 meters per second equals a negative 1.5 meters per second squared times time. Then I can divide by a negative 1.5 meters per second squared on both sides. And that's where I got the 6.67. Let's talk about where the units came from. So we have meters per second divided by meters per second squared, which is the same thing as meters per second divided by meters per second squared, which means that I'm going to flip the second fraction and multiply. So the meters cancel out, and one of the seconds cancel out, giving you seconds. Alright, in part B, we're trying to find displacement. Now, to solve part B, you have multiple options, because you now have the time. Or you could use the one equation that does not have time in it. So it does not matter which of the kinematic equations you use to solve for displacement, as long as you get the same displacement as I do. I chose the one that was already solved for displacement. So the fact that displacement is equal to velocity initial times time plus 1/2 acceleration times time squared. So for my initial velocity, I plugged in the 10 meters per second, and I plugged in the time I found in part A, and I'm plus 1/2 times the negative 1.5 meters per second squared times 6.67 seconds squared. Now let me expand the math a little bit for you. So we're going to have displacement is equal to, let's say we're going to take 10 times 6.67, which is going to be 66.7. Now let's look at the units down here. We're taking meters per second times second. The seconds cancel out, and we're left with meters. And we're going to take that plus 1/2 times the negative 1.5 times the 6.67 squared. So that gives us a negative 33.37. Let's look at the units for that. We have the 1/2 is unitless, so we have meters per second squared times seconds we've now squared. So the seconds squared cancel out, and that gives us meters. So notice these terms both have units of meters. When you add and subtract, you have to have the same units. You can multiply and divide with different units. You've seen me canceling units out in the process of completing this problem, but when you add or subtract, you have to have the terms have the same units. I now can take the 66.7 meters minus the 33.37 meters, which gives us about 33 meters, which is greater than 20 meters, so yes, the car just slid into the meadow. Now notice I expanded on the algebra. I've done that to help you out in case that it's been a while since you've taken a course with algebra in it. However, the minimum amount of work that I'm looking for is the equation, the numbers plugged in with units, and an answer with units. You can show these steps if you want to. A lot of times it's easier to write stuff down rather than doing everything in your calculator, but they are not required.